Okay, I'll repeat myself. A student was asking, it's yes, we know the tools to go from equation to graph, but how do we go from graph to equation? So here's an example. I have a vertical asymptote 2, vertical asymptote 7. I've got x-intercepts 0 and 9. I have a horizontal asymptote at 4. That's enough clues. See what you got. I'm going to give you 5 minutes for this. Because questions like this you should have seen already. Where's my timer?
You go through the steps
Sure.
What did you want?
No, just give me an equation. I'm gonna leave this for Mr. Baird.
First, you find the intercepts. Yeah. One intercept.
Oh, sorry. That makes sense. That'd be silly.
Can it be in factor form?
Yeah, you can leave it as any form you want. Yeah, and just hold on. Just think for yourself and see if it meets all the criteria. Well, you try to confirm that. Pretend this was an actual thing, an actual test. Okay. Test all 4 individually. Do your DIAC in reverse. And then try it back in normal, in regular direction. Take your equation and see if you can graph it or find the key features and see if it agrees.
Is that the horizontal last one at 4?
Mm-hmm.
You guys notice that here or not?
9. Not much time. 1 minute. So if you're done earlier or ahead of time, that's a good place to be. But what's nice about these kinds of questions is you can backtrack. You can pick the equation you found and see if you can get the same graph by drawing it. You may not have time for it during a test, but it gives you more confirmation. Twenty seconds. All right. Let's do this. Okay, here's how I would break it down. You don't have to follow me per se, but this is just another strategy you can use. Vertical asymptotes, that tells me I don't know what the top is, but I do know the bottom has to involve this. It has to. Vertical asymptote. X-intercept is a 0 and a 9. That means the numerator could be a 0 or a 9. Or sorry, the numerator becomes a 0 if I plug in an x as 0 or a 9. So I do know that this is going to have some x and some x minus 9 up there. I don't know if it's squared. I don't know if it's cubed. I just don't know. All I know is that this makes the y value equal to a 0. Right? Y-intercept of 0, 0. When 0 is plugged in, I get a 0 out of it. Yeah, that still falls under the same idea right here, right? That's what the y-intercept means. So I don't have to worry. And the last part, horizontal asymptote is a 4. That automatically tells me two things. Number one, it has to be the same degree. Right? That's one thing. The second thing it tells me is the numerator must be a 4 to 1. It could be a 8 to 2, 12 to 3, whatever, but it's got to be something like this. Something like that. So put this all together and see if you can find an equation that works. So let's see. The numerator has to be x minus 9. This one is x minus 2 and x minus 7. That's already satisfied. It has to be a 4. Does that work? X squared, 4 is up, it's a leading coefficient. That could be 1. Yes.
Can you give us like a harder one that would be? Or would this be?
I mean, if it's a hard, I mean, it could be a T question. Yes.
I'm confused how horizontal asymptote tells you that it has to be a 4-to-1 ratio.
Pardon?
How do you? Why does that make sense?
For a couple of reasons. The short way. Oh, by the way, this is probably also, it was upside down, so maybe I should have talked about that. I'll talk about this in just a second. It'll be a negative, okay? To get to horizontal asymptote, why does it make sense that the degrees are even? All the other forms will not have this as a possibility. Let me explain. If it's a 1 over x, as x approaches infinity, the end behavior is a 0. Same with x over x squared. When you factor out the x, blah, blah, blah. In other words, anytime the denominator is larger in degree, horizontal asymptote should be on the x-axis. Let's go on the flip side. If the numerator is larger in degree, when you do long division, your final end behavior will behave like either a line, it could behave like a quadratic, a cubic, so on and so forth. In other words, it would never be a single constant representing a horizontal line.
It would only be that.
The only way this is possible is by the end behavior, they're both sort of cancel each other out. They divide each other out. That's the only way that's possible. Let's talk about why that's a negative. Question?
After that.
Okay. Okay. There's a couple of ways you can do this. If you wanted to assure yourself that it was correct, you could have done the chart method and you would have seen that the signs are flipped. You could have seen that this is what you would have from here is, let's see, negative to 0, and then positive to 2, and then negative to a 7, and then positive to infinity. Right? You would see that this was actually flipped. We should start with the positive, but here it's starting with the negative. So you know that everything has to be flipped over. Another way you could have looked at it is knowing from your practice that anytime there's two vertical asymptotes, you always have this pattern. It's another way you could sort of guess. Another way you could do is use this and test the point. When you test it, let's say equals a 5. If you plug in a 5, check what happens. 4 times 5 times 5 minus 4, that's a negative 4. Denominator, 5 minus 3 is a 3. 5 minus 7 is negative 2. Am I wrong? Is this correct already?
The first one without the negative is correct.
Oh, shoot. I meant to do it the other way. Really? Infinity over infinity is a 4. Okay, never mind. Sorry, I made a mistake. This was actually correct. I actually legitimately thought this was negative because it's supposed to be flipped upside down. I guess I'm lacking practice. Okay. Just to ensure that your graph is correct, you can just plug in an accuracy point, is what I was trying to get at. What else is there? I guess that's it. Let it be known that I'm not going to try to trick you per se with like negatives and positives. I am looking to see how well or how thoroughly you are able to look at a graph and identify the equation. Or if I give you a list of key features, whether you're able to work around it. Here's another set of key features to see if you can graph it properly. Let's start with a whole. Not sure if this makes sense. I'm just writing random things. Let's see. It just says, sure, let's do that.
What do you want us to do? Graph or make an equation?
Just make an equation. Let's say I don't even have the graph. Like, what if you I gave you a list of things like that? Oh, I still want to do this though. Pardon? Yeah, there's a lot of things I want to do before we go today. I won't spend so much time on this.
Oh, he doesn't hit you at all. I think nothing they do.
No, you can definitely handle 4.1 today. Just give you another minute while I do some cut and paste. Oh. Oh, there was a thumbtack there. I didn't even know. Oh, my name is Bruno. All right, let's get to this final one. Continue. All right, here we go. Oh, what does this tell me? Anyone want to offer their thoughts? Jamie?
There has to be an X minus 3 on the top and the bottom.
Yes, because they need to have cancel each other out, right? X-intercept. Someone else. Go ahead, Anna. On the top, right? It has to be there. Y-intercept? Yeah. When X is a 0, the equation has to equal a 2. We'll leave that there, okay? Because we don't know what other numbers will equal. Vertical asymptote? Someone else? Go ahead. X minus 3 or X plus 3 on the bottom. Okay. And
Negative 1 on top and 1 on the bottom.
okay, so negative somewhere, -1 somewhere, it has to be there. And again, I don't know what it is, but it could be this, it could be this, it could be x to the power of 3 over x to the power of 3. It has to be equal degree. So let's put it together. Okay. Okay. Oh, I could be wrong with the y-int.
You're not. I checked it.
Really? Are you sure?
You forgot the -1. But
No, I think I'm wrong with the y-intercept. Remember, I was just putting all these numbers together. Anyone find a difficulty with the horizontal or the y-intercept? Yeah, it's a couple of people.
If you plug it into that, it would be.
Yeah, so this is supposed to be a negative, right? And right now the degrees are the same, which means if I plug in x as 0, this is 0, 0, 0, 0. The numerator is minus -15 or positive 15, 0, 0, -9. So the y-intercept should be 15 over 9. It doesn't make sense. It would be way difficult. I don't think it's even possible to have all of these other features with this y-intercept. So Mr. Kim, bad. Okay. Because I was just throwing random numbers in there, but there would be no way that we would have a y-intercept with all the other conditions. Yes. Yes. Not sure if that went through. Okay. Remember, stop here. It is 10:56. Let's take a quick 4-minute break. And at 11 o'clock, I'm going to do just one small thing. You could think about it as unit conversion. You could think about it like that. So just take a bit of a break.